So in this video, we're going to be talking about inverse trig functions, and I'm going to be focusing on an explanation. Now, we already know what an inverse trig function is, but what we don't know are the restrictions on inverse trig functions. Before we get to the restrictions, though, I want to talk about a little bit of symbolism. You might recognize this symbolism here, that if you want to find theta, we've been talking about inverse, abbreviated like sine -1z. Now also, before I continue, in this entire section, theta is still talking about the angle, but you might notice this z here. Z always stands for a ratio, which again, remember that a ratio is a lot of times written as a fraction, but a fraction can also be written as a decimal. So if you see a fraction or a decimal, either of them could be considered a ratio. And also remember that if you plug in a ratio into a function, you get out an angle. If you plug an angle in, you get out a ratio. Now to the new symbolism, this arc business. We have arc sine of z, arc cosine of z, and arc tangent of z. The arcs that are circled in red mean the same thing as the symbolism in green. So if you say find the inverse of sine, another way to symbolize that is arc sine. Does it really make any math difference when solving? Not really. The only difference has to do with restrictions, which we will get to in a little bit. So I just want you to know that if you see me writing either one of these, they mean the same thing. Here are the restrictions that I am talking about. Now we are, as it says here, we are going to show where these come from on the next page, but I just want to highlight here for you that this information will be important later. So it's just nice and organized for you. But it might seem kind of strange right now that the domain of the sign is between -1 and 1. Why is that? Why is the range between -π/2 and π/2? All of this right now seems like gibberish until we actually take a look at the graphs, which we will do so in just a bit. Before we do so, though, I want to talk about what the domain and range is again. So I'd like you to think about, to you, what does domain mean based on this course, and what does range mean based on this course? So please pause now and write down what you think is correct. Well, domain is all possible x values or input values, and range is all possible y values or output values. Now, before we go to the next slide, something from the end of Unit 2 that's going to come in handy during this section is, remember, what happens when you're dealing with inverse functions? When you're dealing with domain and range, what ends up happening? Well, the domain of the inverse function, some of you might recall, was really the range of the original function, and the range of the inverse function really was the original domain of the original function given. So you might remember that we had a couple problems where we switched x and y and then resolved for y. What you were really doing was changing the domain and range, because that is the technical definition of an inverse. So where the x values become the y and where the y values become the x. With that logic in mind, I want to ask what the domain and range of the sine function are. But in order to do that, I want to graph and look at it, because I think visual is sometimes much better. So if you pull up your graphing calculator, I would like you first to check to see if your mode is in radians, because we need, when we graph trig functions, which you'll be doing a lot more in Unit 4, you're going to make sure that your calculator's in radians. So if it is, then you're going to press y equals, and I would type in sine, and anytime you're plugging in an angle, what we're just going to call that at this time is an input value of x. So if you put the basic sine of x function in and press graph, hopefully your graphs are finding kind of like a harmonic motion graph. that looks like it's centered at 0, 0, and it looks like the top value it's reaching is 1 and the bottom value it's reaching is -1. So it looks like to me that the domain of this would be all the way from left to right, or negative infinity to positive, but it looks like my range is stuck between -1 and 1. So let me do a little graph over here, started at 0, 0, and just make a basic sine graph just to have it in the notes. This was 0, 0. Trust me when I say that according to the calculator, and something you will be doing in Unit 4, that this point is really pi over 2 over and 1 up. As we said, looks like the range was starting at 1 there. And this point is negative pi over 2, comma -1, so the lowest point is -1. So what is the domain of the red graph you see? Well, looks like it never stops, so negative infinity to positive infinity. What is the range of the sine graph you see? Looks like you're going from -1 to 1 included. Here's the problem. So how do the domain and range of a function relate to the inverse? So how does sine relate to arcsine? Well, remember what I wrote earlier, that the definition of an inverse is that the domain and the range change places, because the domain is replaced by the range and the range is replaced by the domain. The problem is, something you might remember from the end of Unit 2 is when you're trying to find an inverse, sometimes certain graphs don't have an inverse. For instance, a parabola in Unit 2 did not pass the horizontal line test. So what we had to say was, I'm either going to restrict the parabola to the positive side, or I'm going to restrict the parabola to the negative side, because otherwise it wouldn't pass that horizontal line test. If you look at your sine graph, that definitely does not pass the horizontal line test. So what mathematicians artificially did was restrict the sine function between negative pi over 2 and pi over 2. And if you look at this little blue chunk, that piece of the sine function would pass the horizontal line test. So I'm going to draw that little piece here, and I'm going to write negative pi over 2, comma -1, and I'm going to write pi over 2, comma 1. Remember, these values will make more sense when you're graphing in Unit 4. So now if I'm thinking about finding the domain and range of my inverse, remember that the range of the inverse is really based on the domain, and the domain of the inverse is originally based on the range. So that means that my domain is now going to be -1 to 1 of the sine function. But my range can't be negative infinity to positive infinity because the horizontal line test wouldn't pass. So my range would now be from negative pi over 2 to pi over 2. And so if you look back at the original slide, these ones I told you to circle, that is why the range is between negative pi over 2 to pi over 2, and why the domain is between -1 to 1 because of the graph. Something else to note at this time is if your range is between negative pi over 2 down here and pi over 2 here, that means that your sine function is stuck in these two quadrants, or quadrant 1 and 4. It might be useful to keep that in mind. If we look at the cosine function, I'd like to do the same thing. I want to clear this, go to y equals, and I want to type in cosine of x instead. And if I graph it, it looks like, again, we have some harmonic motion, but it looks like my graph starts not at 0, 0, but 0, 1. It looks like the range is from -1 to 1, and it looks like the domain is from negative infinity to positive infinity. So, again, what I'm going to do is draw a basic graph. Starts at 0, 1, goes down, up, and so on. Down, up, and so on. This point is at 0, 1. Again, please trust me. This point is at pi, comma -1. That has to do with the unit circle, but we'll get to that in Unit 4. What is the domain of this cosine function? Well, never stops from left to right. So the domain, just like the sine function, is negative infinity to positive infinity. The range looks like, again, it's from -1 to 1. So my range is the same also as the sine function. When you're dealing with the inverse, how does arc cosine relate to the original function cosine? Well, the domain and range, it's an inverse, so they switch, which means, do we have to make any restrictions? Well, does this pass the vertical line test? No, it does not. So mathematicians, again, artificially decided to restrict the cosine function from here to here. So if you look at that little blue section from here down, or from 0, 1 to pi comma -1, this piece does pass the horizontal line test. So if I want to find the domain and range of these two, of this inverse cosine, the domain of the inverse is the range of the original. So my domain is, again, -1 to 1. My range of the inverse is dependent on the domain of the original, but again, now this is restricted. Where is it restricted? Well, it's restricted from, because remember it came from the domain, so we need to think about x values. It's restricted from 0 to pi. And if you're thinking about quadrants again, 0 to pi for x values, you start here, end here. So it looks like the cosine is restricted in quadrants 1 and 2. Tangent is the oddest one of all. If we graph this one and type in tangent, type in tangent of x, press graph, it looks like you have a crazy graph that's jumping all over the place. Well, these vertical lines, you might remember from your Algebra 2 days, or even Algebra 1, called asymptotes, where your graph cannot touch those vertical lines. So this looks a little messy. So let me show you what the tangent looks like a little bit more neatly. Looks like you have a bunch of cubic functions, and then you have a vertical line you cannot cross, another snake-looking thing, another line you can't cross, and that continues on forever. Now again, please trust me when I say it has to do with the unit circle, but the values that you cannot cross are any multiple of pi over 2. So the domain of your tangent function from left to right is all real numbers except multiples of pi over 2. So really anything but these vertical lines here. The range is not affected, though. You're still going from -infinity to +infinity, so the range is still all reals. But then the restrictions, if you think about it, will this pass the horizontal line test? No, it will not. So again, what mathematicians did just to make it easier was focus on this middle snake or this middle cubic here, because it went through 0, 0. And when you're looking at the unit circle, everything's based around 0, 0. So a lot of mathematicians like that. So we want to focus just on this piece. And if you remember from the earlier part, you can't have any multiples of pi over 2, which means if you want to find the domain and range, your domain is based on the range of the original, so it's still -infinity to positive, so your domain is not restricted. Your range, however, is stuck between -pi over 2 and pi over 2, just like the sine function. So your range is from, this time actually let me erase that, because this time you can't touch the pi over 2's. So your range would be -pi over 2 to pi over 2, but you can't include the pi over 2's. So that means that just like the sine function, your tangent function is possible in the first and fourth quadrant. So as a summary, tangent is restricted between quadrants 1 and 4. Cosine is restricted between quadrants 1 and 2. And sine is restricted between quadrants 1 and 4. We're going to be using this in practice in the next couple videos, so I will keep reminding you of these restrictions. Even if this is a little confusing now, trust me that seeing the graphs is going to help you at least understand where these restrictions came from in the first place. So at this time, please go to the next practice number 1 video for this section.